Roughly 10,000 years ago, a star reached the end of its life and tore itself apart, going supernova in a massive cosmic explosion, leaving behind what we see today as a beautiful supernova remnant called the Veil Nebula. It's one of the biggest objects in the night sky, and yet most people probably don't even know that it's out there. In this video, we're going to explore these incredible objects a bit deeper, and I'm going to photograph the Veil Nebula for myself using my own camera and telescope. I think the best way to explain supernova remnants is to take a look at a different one in our night sky, the Crab Nebula. This one is special because we know exactly when it started. It's the result of a star that reached the end of its life and went supernova in a massive explosion in the year 1054. The Crab Nebula was discovered in the 1700s. It wasn't until the 20th century that we were able to connect it with this explosion that happened in 1054. Scientists looked at records kept by Chinese astronomers from almost 1,000 years ago. These early astronomers took note of the position of the stars around this explosion, and it matches up to exactly where the Crab Nebula is today. Back when this supernova happened 1,000 years ago, it would have looked like a really bright star that was even visible during the day. Now it has expanded into what we see as the Crab Nebula today. And I find that to be incredible, because so often when we talk about space, the timescales are so long, hundreds of thousands, millions, or even billions of years, and that's just impossible for us to wrap our heads around. But here with the Crab Nebula, it's one of the few objects where we actually know exactly when it started. What was a star in 1054 is now the Crab Nebula in 2024. Now let's go back to the Veil Nebula, the supernova remnant that I'll be photographing in this video. Scientists estimate that it's the result of a star that exploded about 10,000 years ago. But that led me to ask another question. We know that the Crab Nebula is exactly 970 years old, because we have record of when the supernova that caused it happened. But there weren't astronomical records being kept 10,000 years ago. So how were we able to estimate how old the Veil Nebula is? The answer I found blew me away. The Hubble Space Telescope captured a super detailed image of a small section of the Veil Nebula in 1997. Then, almost 2 decades later, in 2015, the Hubble team went back and photographed it again. By the way, this image is way more zoomed in than the one I'll be taking later in this video. Do you see what's happening? Hubble is so zoomed in that you can see the expansion of the Veil Nebula. Here's 1997, and here's 2015. 1997, 2015. By measuring how fast the nebula is expanding, astronomers were able to work backwards to figure out how old the Veil Nebula really is. In other words, when did the supernova that caused it originally occur? The answer is about 10,000 years ago. This shows you just how powerful Hubble's optics are, that it can see the expansion of the Veil Nebula by comparing images that are taken less than 20 years apart. We don't see this with most other objects. Galaxies and most nebula would look pretty much the exact same if you compared pictures taken a few decades apart. You would need a lot more time in between images to notice any difference. This is why I find supernova remnants to be so interesting. They are giant cosmic explosions that are expanding so fast that we can observe it as it's happening. And I'm super excited to get outside and photograph the Veil Nebula for myself. To do this, I'll be using my RedCat 51, my wide-field refractor telescope that's perfect for imaging larger targets in the night sky, like the Veil Nebula. I'll also be using my astronomy camera, and it'll be all on top of my Star Adventurer GTI mount. The key to taking this image is this filter that I recently picked up. It's called a narrowband filter, which means it only allows certain types of light to pass through. This one is designed specifically to only allow in light emitted by certain nebulas, like the Veil Nebula. It does a great job at blocking out everything else, which is a big help for me because I'm taking this image from a suburban location, and this filter will do a great job of blocking out most of the light pollution, which will allow me to photograph this nebula in even greater detail. Now it's time to get outside and start imaging. First, I set up the tripod and the mount, followed by the camera and telescope. After plugging everything in, it's time to start taking pictures. I point my telescope at the Veil Nebula and take my first 3-minute exposure. Even in the single 3-minute shot, and without the color being processed yet, you can already start to see the ripples and shock waves of the Veil Nebula. Now it's just a matter of taking as many 3-minute exposures as I can. I was actually able to get outside and photograph the Veil Nebula on the following night as well. In total, I captured over 5 hours worth of 3-minute long images. Here's what my final picture looks like. Even though the Veil Nebula is over 2,000 light years away, it's so big that some of it is out of frame. Here's how large the full moon would be if it was in this image. This is a truly massive section of the night sky. The center of this explosion, where the supernova that created the Veil Nebula happened, is near the bottom of this image. You're looking at about half of this supernova remnant, the section that's known as the Western Veil Nebula. Enhanced by my new filter, where you see the color red, that's hydrogen atoms, and the blue sections are filled with oxygen. You're seeing the ripples, shockwaves, and filaments left behind from a star that exploded 10,000 years ago. All of the material that was packed into that star has now been shot out into space, putting on a beautiful display for us to see. Here is the brightest, most well-known section of the Western Veil Nebula, the leading edge of this explosion. While these brighter sections certainly catch the eye, when you look closer you can see that this image is packed with fainter sections of the nebula. And if we zoom out and look at it all at once, you really get a sense of what you're looking at here, the expanding remains of a giant stellar explosion. This is the first image I've ever taken with this new filter, and I think it's one of my favorite shots yet. When you take the time to really understand what's going on here, and to learn how supernova remnants, like this one, form, it makes the final image a lot more special. I hope you enjoy the final picture, and maybe learned a thing or two about these incredible objects along the way. Thank you so much for watching, and until next time, clear skies.